Hello everybody, and welcome to example 4 on page 32 of the workbook. Now let's take a minute to read this question together here. So in each of the following, we're given a description of a function f, and they would like us to sketch a graph that matches the description, and then to indicate whether the function, its first derivative and its second derivative are positive or negative. That's the last part. Okay, so I'd like to talk our way through part A first here. Let's read what they're giving us. So P equals f of t gives the population of a bacteria colony after t hours. Okay, and they're giving us some information about how this population behaves. In particular, it increases, and also the rate at which the population grows increases. The question is, how do we draw a graph that kind of incorporates all of that information at once? Okay, well, let's just give it a shot over here. So we've got axes already for us. So the first thing they tell us is that the population increases. Okay, so we know it's going to be going up, left to right, so we maybe draw something like that. Okay, what do you think about my first attempt? Would that be an accurate graph? Okay, well, I think it works for the increases part, but what about the second part? We also want the rate of growth of the population to increase. The way that I drew the graph, is the rate of growth increasing? It really isn't, because notice that if we draw tangent lines, the slopes don't change. And so the way I drew my graph, the rate of growth stays constant. It doesn't get bigger. So how would we fix that? How could we redraw the graph so that it's not only increasing, but the rate of growth is picking up? Okay, well, if you think about it a little bit, we just need to change the shape a little bit. Okay, so we'll draw it so that it's increasing, but the slope increases, so maybe something like that would work. Notice that now, if we draw in tangent line slopes, those slopes are getting bigger, and that kind of hits the second part of this statement. That tells us that the rate of growth is getting bigger. Okay, so second part of this question wanted us to determine whether the function, the first derivative, and the second derivative are positive or negative. Let's look at those one at a time. Starting with the function. Okay, so f of t is just representing population. And population obviously has to be positive, so we know that the function itself is positive. Okay, I'm just going to add a kind of a verbal description so you can see where we got the statement from. Now, what about the first derivative? What is that measuring? Okay, well, that's measuring the rate of change of population. That also has to be positive because the population is increasing. It's getting bigger left to right. The function that we drew is an increasing function. Okay, that's how we know that the first derivative is positive. And what about the second derivative? Is that positive or is it negative? Okay, well, remember what the second derivative represents again. It's the rate of change of the first derivative. So we're asking about the rate of growth of the population. Is the growth rate of the population getting bigger or smaller? Well, we can see here that it's getting bigger. That tells us that the second derivative also has to be positive. Okay, so I think we've answered the question. We've given reasons for our answers in each case. Okay, so we're ready to move on to B. And what I'd like you to do actually is maybe pause the video at this point and see if you can do part B on your own first. Okay, it's the same type of question as what we just did. I think that would be good practice for you. So try to do part B on your own, and then after you think you've got an answer, go ahead and resume the video, and you can look at my solution and see if it agrees. Okay, welcome back. So hopefully you've given a try to part B here. Let's work through it together now. So in this problem, they're giving us a function h equals f of t. It represents temperature in Fargo, North Dakota after t hours. Okay, and they're giving us some information about how this function behaves. They tell us that the temperature is below zero the whole day. Okay, that sounds harsh, but believe me, if you've ever been in Fargo, North Dakota, that is not an unrealistic assumption that we're making. Okay, and then reading further here, they tell us that it steadily warms up during the day, but the rate of warming decreases with time. Okay, we're going to try to draw the graph of a function that kind of has all three of those properties at once. Okay, so if we start with the below zero the whole day part, that tells us that our function has to be down here, okay, below the t-axis. And we know that we're steadily warming up, okay, which means that the temperature is going to have to increase. Okay, so I know that we're going to start maybe somewhere down here, and the temperature is going to grow. Okay, so here's my first attempt at a graph. Okay, so we're below zero, and the temperature is increasing. But what about the rate of warming? Okay, they tell us that the rate of warming actually decreases. Is that true for the function that I drew? Okay, well, the rate of warming is about looking at tangent line slopes. And notice that because I drew a straight line, the tangent line slopes stay constant. Okay, so the rate of warming is actually staying constant, so my graph doesn't work. Okay, and the question is, how would we change it so that we can get this last condition to be true? All right, well, again, we just need to change the shape of the graph. We want it to increase, but we want its slope to decrease, okay, so that that rate of warming decreases. And we can do that. Let's try this again by just maybe drawing something like this. Notice that it stays below zero, and it is an increasing function. Temperature is getting bigger, but the slope is getting smaller. If you draw tangent line slopes, those slopes actually decrease. That's the rate of that's telling us that the rate of warming is decreasing. Okay, so we've got a good picture here. Let's see if we can look at the three functions one at a time and decide if they're positive or negative. So starting with f of t, is that positive or is it negative? Well, remember, f of t is the temperature, and they told us that the temperature is below zero, so that has to be negative. Temp is always below zero. Okay, what about the first derivative? Okay, well, that's representing the rate of change of temperature, so we have to ask, is the temperature getting bigger or smaller? Is it going up or down? Temperature is increasing. Okay, so the first derivative has to be positive. Okay, and then finally, what about the second derivative? Okay, well, the second derivative is the rate at which the derivative is changing. So we're talking about the rate of change of temperature change in this case. So what's happening to the temperature increase? Okay, well, they tell us in the problem that the rate of temperature increase actually slows down. So that's actually telling us that the second derivative is negative because those tangent line slopes that we drew over here on the graph are actually getting smaller. Okay, well, that was some work, but I think we have finished this problem.